Welcome to GATE CSE. In the previous videos, you have learnt about the consistency and the inconsistency and the solutions for the systems of linear equations. Now, you know how to find whether solution exists or not. Now, if the solution exists, how will you find the solution? So, there are different methods that we'll be learning in this video. What are different methods I can use to solve the equations and get the unknown values? Okay. Then, so out of this, already two we have used. The first one was RREF, okay, row echelon form. Row echelon form is nothing but your Gaussian elimination, method of Gaussian elimination. Okay, and then another one is RREF, reduced row echelon form. So this is Gauss-Jordan elimination. So we'll just understand the difference. In the previous videos, we have solved using both. In some of the videos, when we found rank or something, I have used this. In some, I have just used this. Okay. So now we'll in depth understand how they differ and what they exactly. Already you know how to find this row reductions. Only we'll see map them to this elimination techniques. Then you can also find the solutions using inverse of a matrix. This also you know how to find the inverse. Then you will also can find the solution using something called as CRAMER'S rule. Okay, we will see this. What is CRAMER'S rule? So let's begin. What is Gaussian elimination? Gaussian elimination is converting the given matrix into row echelon form. So using elementary row reduction operations. So already you know what are the steps. Use pivot element in each row to eliminate variables below it. Transform matrix into upper triangular form. Solve the system using back substitution. This is what we have been doing. Now, let us take an example. I will take an augmented matrix 1 1 1 6 2 1 3 is 10 1 2 3 7. So Gaussian elimination says convert it to row echelon form. So to convert it to row echelon form, let us perform the row reductions. So say R3 is, we try to make zeros below this. So R3 is R3 minus R1. This will become 1 1 1 6 10 11 2 1 3. So 0 1 2. So this is 5. 11 minus 6. Okay, so it becomes 0. Now we try to make this 0 because I am considering this as the pivot element. Now R2 is R2 minus 2R1. This will be 1 1 1 6 0 minus 1, then 1 minus 2 0 1 2 5. Okay. So now this is my pivot element. Below this are 0. Now if I want to make this second row, this as the pivot element, then this element has to become 0. How it will become 0? If I add this to this, it may become 0. So R3 is R3 plus R2. This is 1 1 1 6 0 minus 1 1 minus 2. Then this is R3 plus R2 side. 0 plus 0 is 0. This will become 0. Now 3 and then 3. Okay. So this is now in row echelon form. So there are two pivot elements, 1 and minus 1, and then below them are elements are zeros. Here also 0. All the columns, elements in the column below the pivot should be 0, and this is right to the pivot is again below that is 0. So there are two pivot elements. This is in echelon form. Okay. Now we'll see what is this Gauss-Jordan elimination. It's same thing, only it is more strict than your row echelon form. So it is called reduced row echelon form. Only thing here is you make each pivot element 1. So all the pivot elements should be 1. All other elements in the pivot column should be equal to 0. So direct solution can be found out without back substitution. Here in this I have to make the back substitution. What is back substitution? Once you get the final reduced matrix, right, row echelon form, then you reduce the equation x plus y equal to something like that. So that by solving one variable, we will get the other variable. That is the back substitution. So here it will not be required because we'll see. I am making it all the pivot element as 1. Each pivot is 1. So even if you are not getting 1, so divide, multiply, or add something and then subtract to make it 1. All pivot elements should be 1. So same example, if I convert the same example, final what I got, RREF form, final RREF form was, I got something like this, 1, 1, 1, 6, minus 2, 3, 0, minus 1, 1, 0, 0, 3. This was in using the Gauss elimination. We found out this RREF, row echelon form. What is this reduced row echelon form? They are saying all the pivot elements should be 1. Suppose if it was 2 here, so you divide this by 2, it will become 1. So this is 1 is the pivot element. Here it is minus 1. How will you make it plus 1? So just perform R2 is minus R2. Just change this sign. So this will become 1, 1, 1, 6, 0, plus 1, minus 1, plus 2, 0, 0, 3, and then 3. So means what? Reduced row echelon form. See, it is a triangular matrix. It's a upper triangular matrix. So it's a upper triangular matrix. Below elements are 0 and there are 2 pivot elements and both are 1. So it's in the reduced row echelon forms. Okay. So now when I substitute here, I need not do substitution here, back substitution. Directly I can get the result. So what is this? 3 z equal to 3. Because this is 0, 0, 3. 3 means 3z equal to 3. So z equal to 1. Then I have y minus z equal to 2. Okay. So y equal to 3. Then I have x plus y plus z equal to 6. My x is equal to 6 minus y minus z. Okay, 6 minus 3 minus 1. So x is equal to 2. So this is how we can get the solutions using Gauss elimination or Gauss-Jordan elimination. Next, you can also find it using the matrix inverse if the inverse of the matrix exists. So for that the determinant should not be equal to 0. You already understood this concept. So what is that we are trying to find? See, this is the system of linear equations. Ax equal to b. A is a coefficient matrix, x is the solution vector of unknowns, and then b is my constant values. Now what is that I have to find? I have to find x. So x is nothing but I can write it as A inverse b, which is taking the inverse of A. So x will be given in this form. So for that, if I find A inverse and then multiply with this column, constant column b, then I will get my vector x. Let's see an example. So this is my system. So you have to find the inverse of this. So how will you find? First determinant? Determinant of A is equal to 8 minus 3, that is 5. So what is A inverse? A inverse is equal to 1 by determinant of A into, for a square matrix, 2 cross 2 square matrix, you can easily find it, right? Just swap these two elements and then change the sign of these two elements. So it becomes 4, 2, minus 3, minus 1. So this is A inverse. So what is x? X equal to A inverse into B. So A inverse is 1 by 5, 4, minus 1, minus 3, 2 into what is your B? 5, 11. So if I multiply this, I will get this as x comma y is equal to 9 by 5 divided by 7 by 5. This is another method to find the solutions. So one method is Gaussian elimination, that is RREF. Second one is Gauss-Jordan elimination, that is RREF. Then you have taking the inverse of the matrix. So similarly, you can find solution using inverse of 3 cross 3 matrix. See, 2 cross 2 it is easy, but 3 cross 3 you have to find what? For 3 cross 3 in general, 3 cross 3 or above that, you can find it using 1 by determinant of A into adjoint of A. This is adjoint of A, you already learned. Adjoint of A is equal to cofactor matrix and then transpose of the cofactor matrix. So you find adjoint using this cofactor matrix and then take the transform, you'll get this. So I already solved many problems on this, so I'm not solving it. So you get the A inverse, then again you multiply A inverse into B with this. So it's a lengthy procedure. So if you want, you can apply it, but in the exam, if they ask directly find the solution, you need not apply this because it takes more time. But with this also you can find the solution. Next, Cramer's rule. For a square system, Ax equal to B, okay, square system with Ax equal to B with determinant not equal to 0, the solution is given by xi is equal to determinant of ai by determinant of a. So what you have to do is, let us take this system. So what is this A? Coefficient matrix is 1, 1, and then 2, 3. Okay, and then my B is equal to 3, 7. So what it is saying, first find the determinant of this matrix. So determinant of A is equal to 3 minus 2, that is equal to 1. So it's not equal to 0, hence we can find the solution. Next, I have to find x and y. So how to find the x, y, y is x equal to determinant of Ax, matrix Ax, I will tell how to find it, and then divided by determinant of y. Similarly, y value can be found out as determinant of Ay divided by determinant of A. How to find this Ax and Ay? Ax and Ay is simple. If you are given this matrix, so this is my matrix. Okay, this you assume it as column X and this is assumed as column Y. So when I say Ax, I have to put this B value instead of this column. That is the only thing you have to change. So how it will become now? It will be 3, 7. So this 3, 7 I am putting in this. Okay, and then this part remains same because only I am changing X. I am finding the solution for X. So I am changing only this column. And then this part remains same. So you find the determinant of this. That implies determinant of Ax is equal to 9 minus 7, that is equal to 2. So X is equal to determinant of Ax is 2 divided by 1 is 2. Similarly, Ay is equal to, now you change this with the B values. So this remains 1, 2. This becomes 3, 7. So that implies determinant of the new matrix Ay is equal to 7 minus 6 equal to 1. So this is 1 divided by 1 is equal to 1. So this is how you can solve the system of linear equation using Cramer's rule. We'll take one more example. 3 cross 3 matrix. So what is the matrix? Coefficient matrix A. A is 1, 1, 1, 2, 1, 3, and then I have 1, 2, 3. My B vector is 6, 10, 11. Now find the determinant of A. Determinant of A is equal to 1 into 3 minus 6 minus 1 into so 6 minus 3 plus 1 into 4 minus 1. This will be minus 3. So now you find Ax. So replace this column by B. So Ax will be equal to 6, 10, 11, and then 1, 1, 1, 3, 2, 3. Find determinant of Ax. So this will be equal to, you get it as minus 6. Similarly, Ay, replace column Y. Replace this column with B. So 1, 2, 1, 6, 10, 11, and then 1, 3, 3. So determinant of AY will get it as I think -9. Then AZ equal to, replace the third column, 1, 2, 1, 1, 1, 2, 6, 10, 11. Find the determinant of this AZ equal to, we get it as -3. So X equal to determinant of AX divided by A. So this will be 2. Determinant Y equal to determinant of AY divided by determinant of A. So that is 3. Then Z equal to determinant of AZ divided by determinant of A. So this will be 1. Okay. So that is the answer. So thank you for watching. Please like, subscribe and share. We'll continue with the new topic in the next video.